All right. Hello, everyone. Meteorologist First and Weather here, and it is that time of year. It's time for the 2024-2025 winter forecast. Once again, another definitely very interesting forecast in store for the lower 48 this year. Really have spent a lot of time going to the different variables, the analogs, and all the different, sort of features that I think are going to impact this winter. I'm also going to be taking a bit of a different outlook or kind of different approach when it comes to making my winter forecast this year based on sort of the outcomes we've had over the past couple of years to kind of give you a better idea, more a holistic approach of what this winter might end up being like. So again, yep, my name is Rohan Shroff, aka First and Weather. Take a nice little warm drink or a nice little a mug of coffee, settle down, and enjoy the winter forecast. So let's start off first with one major thing. So learning from failure. This one, I really want to have sort of a different approach to previous years, where you have sort of one default forecast and say, okay, this is what's going to happen this winter for sure. There's no other alternatives. There's no other outcomes. That I think is a flawed approach, especially now in recent years with human caused climate change and other varying factors. I think winter forecasting and subseasonal forecasting in general has become a bit more difficult. And so seasonal forecasting really is, it's chaotic. That's really the best description of it. You know, you might have the most perfect analog set and you end up with a result that's completely opposite of what you're expecting. And that's to be expected in a way. Predicting really is just probability. And so just because you have a high probability of something occurring, that doesn't necessarily mean it's going to actually happen. Probability is inherently likelihood based. And so that's really a key, failure factor when it comes to making winter forecasts. And so, for example, last year in my winter forecast, you know, all the analogs were pointing to, a very active, stormy, snowy season for the Mid Atlantic, and it in fact was the exact opposite. We had one of our warmest winters on record for the lower 48, and we also had one of the least snowy winters on record in the Mid Atlantic. In fact, Richmond International Airport, which is my hometown, saw just a trace of snowfall, tying the record for the least amount of snow ever recorded in a winter season since records began 150 years ago or so. And so there are hundreds of components in a winter forecast, like I've said. So the QBO, the PDO, stratospheric water vapor, water temperature anomalies off the Pacific Ocean. So there's just so many sort of erroneous variables that can really kind of interact and mess with each other. And so I think it's important to place less emphasis on each variable and see, oh, how will this impact the winter forecast by this many degrees, and rather take a more broad-based approach to kind of get a better idea. And like I said before, I think with climate change, we're also seeing winter forecasting becoming a little bit more difficult. Previously, I feel like you would take your analog composite, your set, and make your winter forecast, and you'd be good to go. But I think recently that it has become a bit more chaotic and unpredictable with climate change maybe throwing another variable or a wrench into the forecast. So here are the factors I'll be looking at. Like I said, I won't be looking at these, exactly where these are my, my make or break. Where one factor, if it's a bit off, you just disregard it. It's more about a holistic approach and seeing how all these kind of work together to get a better picture. So, of course, number one, ENSO. It's the number one driver of global weather patterns. You got to look at that. The QBO, PDO, NAO, these are all important teleconnections that help us understand the state of the atmosphere. Also, dynamical weather models. These have been performing really well over the past couple of winters, and so I think it would be a mistake to disregard what these models are saying. I'll also be using my similarity analog tool, which is a Python script I've developed to kind of find similar years in the past based on ERA 5 climate reanalysis data. And then I'll also do a deeper analysis of each analog year composite at the very end of the forecast, and that's where I'll kind of go into my two different scenarios for what I think is likely this winter. So if we take a look now first at ENSO, it's should be no surprise that this winter we are going to be seeing a La Nina. Nothing too strong, weak to maybe moderate, but I think at this point, a strong, cool or a strong neutral event or a weak La Nina is by far the most likely. If you look at the model estimates, You can see how long I've been working on this winter forecast. This is from September 2024. The October forecast has long been released. I should probably update that. But regardless, you get the idea of what's going on here. If you look at the December, January, and February composite, which I think is this line, you can see you're right around negative 0.4 to negative 0.8 degrees Celsius below average in the Nina 3.4 region. So that's, kind of your classic weak La Nina signature taking place. You have some variation between your dynamical and your statistical models, but I think regardless, this is a good base point to really kind of base your forecast off. If we take a look at the sea surface temperature anomalies worldwide, you can see that La Nina kind of progressing nicely here. Big area of cooler than normal waters off the west coast of South America, extending westward into just about 180 degrees west. So this has an impressive westward extent. Some La Nina years typically see their coldest waters just kind of bunched up off the coast of South America, and that can sort of be an East Pacific based La Nina. With this year, we have those waters a bit further to the west. There's one other thing I want to point out here, and that is the record warmth we're seeing off the western Pacific coast, specifically this area right here. This might play a pretty significant role in our pattern. And just a quick synopsis, this is helping to accentuate zonal wind anomalies right in the region north of this. So you have a roaring jet, and that might play a role in sort of limiting Arctic air intrusions for the lower 48. And looking at the past, when you have had that sort of signature, you have seen that effect taking place. You're also seeing the kind of very distinct negative PDO signature, warmer waters here and a cooler horseshoe trying to take shape right around the La Nina. So in that way, pretty similar to most La Nina years as well. Another thing to note is the unusually warm waters south of Greenland. This might be playing a role in cyclone amplification and just in general, the general synoptic state. Now, if we take a deeper look here at ENSO in general, we can see for 2024 we have rapidly decreased from that strong El Nino we had previously, and as of June, I think this is, let me see, January. As of July, excuse me, we're at 0.1. This should go negative as we get closer to the winter months. And this right here is the ONI index, which is just taking a look at the sea surface temperature anomalies. But one thing I want to point out is that with climate change, this metric can be a bit misleading. And I think it's more important to take a look at the anomalies compared to the base state average, or the average of the equatorward regions, to sort of get an idea of how the ENSO event is progressing relative to our new normal climate period. And so that's what the Rani index does. So it takes the average of the Pacific waters to get a better idea, or a standardized idea of ENSO. And you can see when you take this into account, the June, July, August time frame has a value of negative 0.49. Right? And so this can also help to better capture how the atmosphere is actually responding to a La Nina event. And you can see this indicates you're right around the cusp of a weak La Nina. If we look at a diagram right here, which on the y-axis you have depth in meters, on the x-axis you have longitude. So this right here is the east coast, or the coast of South America. This right here is as you go further west. And you can see we have an impressive pool of cooler than average water anomalies just below the surface here. That looks good for La Nina strength. I don't think we're going to see much intensification of our La Nina, but this also points to the fact that it's unlikely we see a rapid collapse of our La Nina event. Now, if we take a look at model forecast, this is the C3S multi-system seasonal forecast. So basically, it combines models from all the major meteorological agencies. So NCEP, the ECMWF model, the Met Office, or the France model, etc., etc. And this right here is the predicted sea surface temperature anomalies for this upcoming winter. And you can see that we have a sort of a basin-wide event. It looks a bit centrally biased. But overall, nothing really too strong in terms of an east or west-based event. This will not be a strictly east-based La Nina or a strictly Molokai La Nina, which is when your waters are, right in the center of the Pacific. I think this is kind of more of a hybrid event, where you're going to have cooler than normal waters pretty much everywhere, from the east coast of South America all the way to the central Pacific. And that has important implications for our upcoming winter. Now, if we take a look at the MEI index and compare it to other years, the MEI index is a sort of metric to see how the atmosphere is responding to La Nina. So you can have, a strong La Nina in the Pacific, but if the atmosphere is not actually responding to the effects that you typically see in a La Nina, so pressure changes and precip changes, then you're not really having a strong La Nina. It's just a strong La Nina on paper. And as you can see here for 2024, it was actually struggling a bit earlier when you had that strong El Nino as expected. But as we've gotten closer now to the summer months and the fall months, we're starting to see the MEI index get a bit closer to other more typical La Nina years, right around negative 0.8 or negative 0.7. So that does indicate the atmosphere is responding relatively well to our La Nina, and that we are firmly entering a La Nina state when it comes to global climate and weather. So if we take a look now at our general La Nina composite, I have taken all La Nina years since the year 1980. So you might be asking why I excluded years before 1980, and that's because I feel like with our changing climate, using analog years now before that period can be a bit misleading because now with climate change, certain things that you might have seen 40 years ago might not really be how the atmosphere responds today. So I felt like it was important to sort of make the distinction. And so anyways, when you look at the composite for all weaker greater La Nina years, since 1980, this is what you get. So you'll notice we have a very strong Aleutian ridge right here, just south of Alaska. General troughing or below average geopotential heights in the center. And just to clarify, this is geopotential height anomalies. And overall, you see ridging in the central, western, and eastern U.S. This would suggest a very warm pattern for most of the country, but a pocket of cooler than average temperatures in the upper Midwest. And that's exactly what you see on the right. These are temperature and precip anomalies. So a bit cooler out in the Midwest, in your North Dakota, South Dakota, Minnesota, but then much warmer as you go down south up along the East Coast. And one thing that's really classical with La Nina winters is the return of the southeast ridge, where you see a stronger than normal ridge off the southeast U.S., especially during the months of February, and that really helps to increase your warmth down in the southeast region right here, and that's notorious for making the storm tracks go inland and be Great Lakes cutters rather than forming off the East Coast and delivering big snows for the Mid-Atlantic and I-95. And accordingly, we can see with precip anomalies, very dry along the southern U.S., down into the East Coast, and then pretty wet as you see in the interior portion of the country, Ohio Valley, interior Northeast, and also the Pacific Northwest. Now, if we take a closer look at the La Nina, again, taking a more detailed look at sort of how this La Nina is behaving compared to other La Ninas, this right here is the Jamstack forecast for the EMI value of La Nina, which is a measure of how centrally or easterly it will be based. As you can see on the figure on the right, an east-based La Nina is more right around, as the name would apply, South America, so more east, while a central or Molokai La Nina, Central Pacific-based La Nina, is further west. So you have the coldest anomaly centered south of Alaska or even further to the west. And so the EMI forecast right here suggests a EMI value of around negative 0.5. So nothing too crazy, but it does suggest a very slight central bias instead of an eastern tilt. And I think this won't really have too much of an impact. I think this is still going to be a basin-wide type of La Nina event this year. Now, if we take a look at velocity potential anomalies, it kind of gives you a good idea of how the atmosphere is really responding to the La Nina. And this is a really good way to see exactly what type of La Nina this is. And so the figure on the far left here shows the velocity potential anomalies for all La Ninas since 1980. Now, one thing you'll notice is very positive anomalies right around here. Central Pacific, very negative anomalies, in the Western Pacific and Indian Ocean. Now, if we take a look at the same chart, but for this year, 2024, and look at the months of July to September, you'll notice that the positive anomalies are much further to the east, right around Mexico, South America, and just to the west of South America here. And then you have below average anomalies in the Central Pacific and also extending further west to, again, the Western Pacific. And so this is pretty important to note here. And the reason it's important is because clearly, as we can see, your velocity potential anomalies are a bit further east than a typical La Nina. So that indicates that the response we're seeing from the atmosphere this year is not your average or very typical sort of mean based La Nina. And so then what you can do is if you go then back to this huge composite of years right here, you can then select years that had the same signature from July to September to see, oh, these years look to have responded more similarly or had a more similar atmospheric response to this La Nina. And so the years are 2022, 21, 2017, 2007, 2005, and the year 2000. And so you can see how nicely these figures match up here. Your biggest peak of velocity potential anomalies is just off South America, same with this year, and your negative anomalies are primarily focused in the Western Pacific and also extending a bit further to the east. And so if we take a look at this figure right here, this kind of just shows you the general sea surface temperature anomalies of the years that had similar velocity potential anomalies to this year. And you'll notice that there's pretty good alignment. You have, for the analog years here, you have a pretty central based La Nina, or basin-wide La Nina, excuse me. With this year, July to September 2024, we also have a bit more westward extent of your cold anomalies. You also have warmer than average temperature anomalies in the Western Pacific, right around here. And as exactly for this year, we have warmer than average temperature anomalies for the Western Pacific as well. Another thing we can look at is the MJO, or the Madden-Julian Oscillation. So how is the atmosphere responding to this year's La Nina? And a great way to see that is by looking at the MJO, or precipitation anomalies in the Western Pacific. So right around here. The figure on the left has MJO phases, so phases 1 through phase 8. Each phase correlates with different precipitation anomalies in different zones. And the model forecast on the right shows projected precipitation anomalies for December through February. And you can see that it's showing much above average precip predicted for Indonesia, eastern parts of the Indian Ocean, and also just north of Australia, so right around here. And that correlates pretty nicely to phases 4, 5, and 6 of the MJO cycle. And those phases are pretty common in La Nina events, and they do help promote also warmer conditions in the eastern US, drier conditions along the coast, and your typical La Nina pattern. So good alignment here. The MJO is responding well, or the model forecasts are picking that up nicely, and in general helps to increase confidence that we are seeing typical atmospheric responses to this La Nina event. Let's take a quick drink of water here. So now if we look at the modified La Nina composite, so if we take a look at the years that have a similar velocity potential signature and only look at those years, what's the picture? So unfortunately for snow lovers, it's even warmer. So you have still your strong heights over Alaska or below Alaska, some troughing in the central Canadian region, but then also wide base ridging, along the east coast, the southern US, and also the western Pacific. And, pretty much no high latitude blocking on our side of the northern hemisphere. And if we look at the temperature and precip anomalies from these 5 years or so, you'll see that we have, pretty similar or anomalies that you would expect to see. Very warm along the east coast and a bit cooler than average in the upper Midwest. So again, a jet stream that's kind of like this. So storm track, a bit further to the west. And your precip anomalies also help to support this. So very wet conditions in the Ohio Valley, the central and interior portions of the Northeast, but also very dry conditions along the southeastern United States, going down into Florida, Louisiana, Texas, and also very dry in the Pacific Northwest, extending down into California. Now, if we take a look at the month-by-month basis of this analog, we can see that December really has the most variation. You can see we have that troughing extending a bit further south. That ridging is a bit more suppressed. Some evidence of high latitude blocking in Greenland, which might help to increase storminess. And as a result, the December analog does have the potential to see some cooler than average conditions extending down onto the East Coast. And so I think this is the time period when you might have some increased winter weather. But then as we transition to January and February, we can see things quickly change. With January, no high latitude blocking, the return of some pretty extensive ridging, and as a result, we see very warm temperature anomalies for much of the U.S. And for February, we have sort of this very polarized setup here with strong Aleutian ridging south of Alaska, very or well below average height anomalies in Canada extending down into the upper Midwest, and then that very strong southeast ridge steering storms up and west of the East Coast, bringing well above average temperatures to this region with below average conditions to the west. So now we can kind of switch gears and take a look at the QBO and other teleconnections. So the QBO, or the quasi-Banal oscillation, is currently in its westerly or positive phase and is expected to continue to be in that phase as we go forward. Ignore this image right here. This is outdated. But for the 2024 year, we're also seeing rising westerly values. And so this analysis here done by Frontier Weather and Weather Deck Tech shows what the trend is during QBO winters. And so generally, eastern U.S. winter temperatures are more likely to be colder than average when the QBO falls during winter and is more likely to be warmer than average when it is rising. And so this year we are seeing the QBO anomaly rising and also in the westerly phase. And if we look at the figure on the right, that is figure D right here. And so that suggests we have increased odds of seeing above average temperature anomalies along and east of the Mississippi. We can also take a look at the North Atlantic Oscillation. You can see this is the ECMWF long range forecast, and generally I don't really put too much weight into these. I think this year, especially looking at the analogs, or NAO will be more variable. I think it will be sort of transient, where we don't really see any long-term sort of negative NAO regimes. We might go negative for a couple weeks or a few days, but predominantly we're going to be around neutral to, if not a positive NAO, which should help to keep things relatively dry along the East Coast and limit significant cold air intrusions. We can also take a look at this figure right here. This is from a paper that shows the correlation between the Nino 3.4 and also the NAO index. And you can see that in cooler La Nina years, there are some years that are biased to see a negative NAO. But this right here is for Eastern Pacific-based La Ninas. This winter is going to be more basin-wide. And so I think there isn't really a strong signal for what the NAO will be this winter as well from this research. Another thing to talk about, like I mentioned before, is the Pacific Decadal Oscillation, or PDO. This year as well is year 4 or 5 of just record negative PDO values, and historically speaking, a negative PDO reinforces troughing in the west and ridging in the east. So warmer conditions in the eastern U.S. and cooler conditions in the western U.S. And so this is largely being emphasized by this record-breaking warmth in the Western Pacific and this horseshoe of cooler than average waters hugging it along the east. And so this also provides good evidence that the atmosphere is responding in accordance with the La Nina and is currently seeing negative PDO conditions. So now if we take a look at all the analog years, so all the years after 1980 that were La Nina, and then highlight in red the years that had similar velocity potential anomalies, we can kind of group the winters into different zones. And if we focus on the selected analog years, so years that had similar velocity potential anomalies, you'll notice that we have in group number 1, which was warm east and cold west, 2022, 2023, 2007, 2008. Now, group number 2 is a warm, or most of the country remains warm while the Midwest is cold, and that is 2021, 2022, and 2017, 2018. 1 year is all warm, which is 2005 to 2006, and then 1 year is all cold, which is 2000 to 2001. This was a really cold year where we had a polar vortex disruption and stretching, which helped to unleash Arctic air for much of the nation in December and also parts of January. So now before we go into further detail, I'm going to take a quick break here, and then we can get right back into the video. All right. So one thing that we can do is to sort of decrease uncertainty in our winter forecast is look at the cold years in our analog composite. So as you can see in the slide above, there are some years which had cooler than average conditions. So one of them is the group number 4, cold east and warm west. You might remember the winter of 2013-2014. That was a very notable winter with the polar vortex making things downright frigid for much of the East Coast and record snowfall in the Northeast as well. So if we take a look at those winters that were in fact cold and kind of plot the velocity potential and geopotential height anomalies, we can get a better idea of what exactly happened. And one thing I want to point out is in the image on the far left, you'll see that the colder winters do not have a similar velocity potential signature to this year. So for 2024, we have above average or positive VP anomalies along South America, but in this composite right here, we have negative conditions along South America, and those positive anomalies are shifted much further to the west in the Central Pacific. And so this suggests that the cold anomaly winters are not sort of what we're seeing this year. And this is, and the figures on the right here kind of just show the geopotential height anomalies for those cold years. So in one group, you have 2001 and 1984. So, pretty significant ridging in Alaska, helping to ensure cross-polar flow. Below average geopotential height anomalies in the central U.S. And then same thing in the right with even more impressive ridging in Alaska, negative NAO signature, keeping things quite cold over the central U.S. Now we can switch gears to my similarity tool. So this is a Python script I made which looks at geopotential height anomaly data for every year since 1980 and looks at each month from April to September and kind of compares and sees which years in the past are most similar to what's happening this year. So the logic is that if we look at years that are behaving similarly to this year, we might get a better idea of how this winter might progress. And so the image on the left kind of just shows you what the model is calculating. So these are geopotential height anomalies standardized. And the image on the right shows the domain I was working with. So I wanted to look at ENSO, of course. I wanted to look at the MJO signature and also the Pacific and also general conditions over North America. And this is the result. So the year with the best score, or the lowest MSE, was 1998 to 1999. And the scores for all years are listed here. You'll notice that every single winter, or the top 3 analogs, were all warm, while the only cold winter was 1983 to 1984, and 2005, 2006 was varied. So I want to note here that there is significant variability between the years, but the fact that 1998, 1998, and 1999 are so similar to this year does increase my confidence that we are going to see warmer than average conditions for the lower 48 for the majority of the winter. And so this image in the center right here is the geopotential height anomaly composite for December through February for all 5 of these years. And you'll notice that there's very little high latitude blocking in the northern hemisphere. Significant ridging out west, significant ridging east of the Atlantic or east of the East Coast. And that in general just kind of floods the country with warmth here. Warmth in the Midwest and Northeast, warmth in the Southwest U.S. as well. And interestingly enough, it does show above average precip anomalies along the East Coast. I think this is being skewed by a couple winters like 2023, but that is interesting to note. Now, if we take a look at the modified analog composite, so this is the initial 5 years or so that have similar velocity potential anomalies to this year. I have also now added 1998 and 1999, or the winter of the 1998-99, because of how similar it is. And if we look at the modified or the new analog composite, we notice that we kind of have a similar picture here. Above average heights are ridging south of Alaska, limited high latitude blocking, troughing in central Canada, and extensive ridging in the East Coast and the southern tier of the U.S. And so the result with that in terms of temperature and precip anomalies is above average to well above average temperatures on the East Coast, a slight signal for cooler than average temperature anomalies in the Midwest, and then for precip, quite wet in the Ohio Valley, interior Northeast, and then quite dry in the southern U.S. as well. Now, this right here is taking a look at a month-by-month basis. So how does this analog composite look for every single month? So again, these are the winters right here that I'm looking at. For December, again, this is the year with the most sort of variability. Some Decembers were very warm, some Decembers were quite cool. And typically with La Niñas, your winter is front loaded, where the majority of your cold and snow, at least for the East Coast, does take place in December and early January. And so that's why for December, I think there could be a bit of variability in the outcome. And so you see that here with that troughing extended a bit further southeast, that ridging is a bit more suppressed, and you have some high latitude blocking showing up in the analog as well. This right here is the temp and precip signature. So you see this cooler conditions extending a bit further down south, warmer conditions along the southern, western, and southeast US. And for precipitation, we can see still pretty dry here with a relatively weak signal overall for the most of the lower 48. Now, if we look at the month of January, we can see that we have a bit more of a warm signal for most of the country. Significant ridging here, very positive NAO, making things pretty dry for most of the country. We just have that polar jet stream ripping across Canada, very little interaction with the subtropical jet stream. So a very bullish month on lack of snow and lack of cold. And this right here is the associated temp and precip anomalies. You can see very warm for the lower 48, and really nothing going on in precip. Some above average precip right around here, but other than that, just pretty dry and neutral at best. And for February here is the return of the southeast ridge and troughing in central Canada. Another warm signal for most of the eastern US. And as you can see here, this is some of the strongest signature we're seeing for above average conditions in the eastern US. Pretty cold in the Midwest, so I think February might be a month for the Midwest that does see some cooler conditions. And with precip, again, wet in the Ohio Valley and central US and dry along the East Coast. And if we take a look at March here, because March is in many ways part of winter, this is really interesting. We seem to see a dramatic shift in the pattern just as March arrives, with pretty significant high latitude blocking in Greenland and negative NAO and storminess in general being signaled by the analogs here, showing a relatively active storm track, which could deliver, I think, some good storms and good snow maybe to the interior mid-Atlantic and also the interior Northeast. And this is the analog composite for March in terms of temp and precip anomalies. Relatively widespread, cooler than average to average temperatures and warmer conditions still lingering in the deep south. And for precip, still a dry signal for the East Coast and some wetter conditions in the Ohio Valley as well. Now, one thing I think we can also take a look at is the models. The models have been very accurate for the past few winters, and I think not looking at them would be a mistake. This right here is the C3S multi-model system, and it is very, very similar to what the analogs are saying. Extensive ridging south of Alaska, troughing in central Canada, and ridging in most of the U.S. So that kind of increases confidence that what we're seeing right now in the analogs and the models is that we're seeing alignment. And so that does help to increase confidence that this winter will be sort of warmer than average for most of the lower 48. We take a look here at the mean temperature anomaly and precip anomaly. We can see again a widespread warm signal for most of the lower 48. Some signaling right here for below average temperatures in Alaska. And for precip, very similar to the analogs as well. Above average precip for the Ohio Valley, Pacific Northwest, and drier conditions for much of the southern U.S. as well. And this right here is a really interesting or depressing plot if you're a snow lover like me. This is by Ben Knoll-Weather. He produces great graphics. I highly recommend you check him out on Twitter. This right here is the C3S snowfall anomaly. So the projected snowfall anomaly for the winter. This performed great the last two winters, and so for this winter, you can see it's going very, very bullish on almost no snow, or not no snow, but well below average anomalies for much of the lower 48. You can see we have a maximum of below average snowfall along I-95 and the mid-Atlantic here, and also in the western U.S. as well. And if we take a look at on the city basis, this is for Washington, D.C. These are a bunch of ensemble members right here, and their predictions for snowfall anomalies for each month of winter, and you can see most of them are pretty below average. Now, one thing I do want to point out is that you'll see that in January and February, some models do have some significant above average snow months. So I think that the real theme for this winter is that you're not going to have many small, nuisance snow events. I think to really reach average snowfall, to make it a winter that does see good snow, you're going to have to rely on just one big storm where you get real lucky that dumps, a foot of snow to reach your seasonal average in the mid-Atlantic, because the pattern overall is not going to be conducive for widespread winter weather events. I think like 2016, where most of your winter was quite warm and snowless, the pattern got right for 2 weeks, and you had that monster blizzard that hit the mid-Atlantic and East Coast. That's what we're going to need this winter to really kind of have a salvageable winter. And now the next wild card, or transitioning now to wild cards, I think the biggest one is the stratosphere. So when you look at La Nina years that were really warm, like the past couple ones, and then La Nina years that were a bit more manageable with cooler Decembers, cooler Januaries, the main wild card there was the stratosphere. Did the stratosphere have a polar vortex disruption or weakening? And I think there's a few main factors that impact that. Number one, I think, is the QBO. When the QBO is in the easterly phase, you tend to make it easier to have polar vortex disruptions. This year, we're in the westerly phase. The QBO is all, or the polar vortex is also quite strong right now. And I think there's going to be limited chances to weaken your polar vortex as we go further. Another factor, I think, is Siberian snowfall cover. Siberian snowfall cover has been, let me try to find the slide here. Oh, right here. Siberian snowfall cover has been quite, unimpressive. We have anomalies right around average, nothing really kind of promoting energy or wave flux into the stratosphere and the upper troposphere that might weaken your polar vortex. So I think overall, the odds do favor a stronger than normal polar vortex this winter. I think another big factor here is the Hunga Tonga eruption, which unleashed a huge amount of water vapor into the stratosphere, and that might keep the polar vortex a bit more stronger than usual, because we're seeing record cold anomalies in the stratosphere, and that might help to promote a stronger polar vortex. And so now I want to take a look at different scenarios. So this is what I'm saying here, but wait, 2000, 2001, the winters of 05, 06, and 2017, 18 did feature colder months during the winter as a result of a polar vortex disruption and warming. And so those years all had a negative QBO. Like I said before, this year is a positive QBO. And so that doesn't mean a polar vortex disruption or weakening is out of the cards. I just think it makes it a bit less likely. And so the figure on the right here shows 10 millibar geopotential height anomalies for December 2000. And you can see we have a very kind of signature weakened polar vortex. You can see that stretching taking place, delivering colder shots to the lower 48 as it does transition down into the troposphere. Now this figure right here shows December through January temperature and precip anomalies. Or let me see. Figure right here, shows December through January temperature anomalies on the left, and then December through February temperature anomalies on the right for the winters in my composite that did end up a bit cooler than normal. And so you can see that in these three winters right here, you did in fact see below average temperature anomalies for the East Coast, pretty much east of the Mississippi, and warmer conditions out west. So you would think favorable conditions for, snow and winter weather events before, when you look at and then transitioning to a more warmer pattern in February. And that reflects nicely here on the figure on the right with, cooler conditions in the Midwest, but in general, warmth along the West Coast and also the East. So it kind of just goes to show you that even in the analog composite, there is quite a bit of variability. You do have 3 or so winters where you have cooler conditions in the months of December and also the first half of January. And so that leads me to scenarios. Based on what I'm seeing with the behavior of the polar vortex, I think scenario number 1 is the most likely, has a 70% chance of occurring this winter, and that is we essentially see a blowtorch where we have a top 5 warmest winter on record, a very warm December through February for the East Coast, especially February. I think some below average weather and general storminess might be possible in December through early January, but overall, a very warm to record warm winter. Now, I still think March might be a wild card, and also the pattern might set up just right for a couple weeks to deliver a big snowstorm, but overall the winter will be very warm, possibly record-breaking warm. Now, scenario number 2. I think this scenario is quite unlikely, but I do think it cannot be discounted. About a 30% chance it happens, and that is we see a cooler than average December into early January before a massive warm up and record warm February, and some below average temperatures again possible in March. The winter ends up average to slightly above average in terms of temperatures for the East Coast with average snowfall. I'll go to the slide here. This kind of explains what I was talking about before. The QBO in the westerly phase. This right here is a chart showing projected stratospheric wind anomalies. And so, again, like I said, the QBO being in a westerly phase helps to strengthen the polar vortex and really prevent it from weakening. And this figure right here shows the Siberian snowfall cover. This is from Judah Cohen. And the figure on the right here shows the model of how enhanced Siberian snowfall cover can lead to wave flux and energy flux, which can then help to weaken the polar vortex. And now this right here is the analog composite for scenario number 2. Again, the less likely scenario, but still important to take a look at. The overall composite, you can see, still has, very little high latitude blocking, but overall less ridging on the East Coast. That strong ridging signature you saw here is kind of gone. If we take a look at a month-by-month basis, we can see that December has troughing on the East Coast, cross-polar flow, ridging in Alaska, and then January and February return to warmer conditions on the East Coast, with ridging and troughing in central Canada, delivering cooler conditions there. So, without further ado, here is my December through February temperature anomaly forecast. As you can see, I'm going pretty bullish on a very warm winter. I think for I-95, the East Coast, the Southeast, well above average conditions, 3 to 5 degrees plus. Above average conditions for the Midwest, or not the Midwest, sorry. States like Missouri, Indiana, Illinois, Michigan, extending westward into Southern California, Arizona, New Mexico. I think temperature anomaly is about 2 to 4 degrees above average. And then as you can see here, getting a bit less above average as you go further north. I think the only part of the country that really has a chance to see below average temperatures is this little sliver right up here around Washington State, Montana, and also northern North Dakota. Now, if we take a look at scenario number 2, so again, this is what's less likely to happen, about a 30% chance. But if we do end up seeing that polar vortex disruption and weakening taking place, I think this is what you'll see. So still above average on the East Coast, 2 to 4 degrees above average. I'm still going with a warm winter for that area. But you'll notice that I have slightly below average temperatures extending further east and also further south in this scenario. So the Dakotas, Minnesota, cooler than average. The average conditions are equal chances a bit further south as well. And the warmth being centered more up along the western U.S. and down south along the eastern U.S. as well. So I think in scenario number 2, because of December, the well above average temperatures will be focused a bit further south and suppressed because of cooler anomalies in the month of December encroaching eastward. Now, in terms of precip anomalies, I have one forecast here. I think you're going to see above average precip again in the Ohio Valley, in the Midwest, or eastern Midwest, and interior Northeast, with below average precip in the southern U.S., extending into the East Coast here along I-95, and also the coastal cities of I-95 in the Northeast as well. And then also some higher chances of above average precip in the Pacific Northwest. Now, if we take a look at snowfall here, this right here is the analog composite standardized snowfall anomaly based on ERIFY reanalysis data. So I took all my analog years. I forgot to put in 2007, 2008 in the title, but it's still in the analog composite. And this is what it spits out. When you look at all those winters, how does the snowfall compare to average? And you'll see we have a pretty pronounced signal here of below average snowfall all around here, below average snowfall in the mid-Atlantic, and some average to above average snowfall in the interior Northeast. And, once you get north of New York City, we do see some above average snowfall in this region right here. Right around here. But it's interesting to note that there's such a pronounced above average snowfall signal or below average snowfall signal in the mid-Atlantic here and also the central U.S. because that aligns almost identically to the ECMF or the C3S snowfall anomaly here, showing well below anomalies in the western US around the Rockies, and also well below anomalies in the western western mid-Atlantic and also the Northeast. The one main difference being the C3S anomaly has below average anomalies along the Northeast, while my analog composite right here shows below average or above average anomalies extending into the eastern US when you go north of New York City. Now this right here takes a look at the snowfall analog composite for those colder winters. So if we take a look at the winters of, I believe it's 01, 5, 6, and also 2017, 2018. So if you ignore these 2 years or these 3 years right here, we see the signals a bit different. So in general, average snowfall for most of the mid-Atlantic, areas of slightly below average to above average, but overall average, and a much more pronounced above average signal for the coastal New England states right here. And so your main below average snowfall signal kind of shifts to the west in scenario number 2. So let me just make that clear. Scenario number 2. Again, I think this map right here is much less likely. I think this is about a 30% chance of happening. I think if I were a betting man, I would put much more emphasis on this figure right here with widespread below average snowfall for much of the US, except besides the Pacific Northwest and also the Midwest and Northeast. And so that leads to my snowfall anomaly forecast. Again, in the brown, below to well below average. That includes Mid-Atlantic, I-95, and above the blue, above average snowfall. So coastal New England or interior New England, the Midwest, and also the northern U.S. as well. And just to note again, like I mentioned earlier, for the Mid-Atlantic, all it really takes is one big storm to reach normal seasonal snowfall totals. I think January and early March have the best chance of seeing this. So again, if you're a winter weather lover in the Mid-Atlantic, don't sort of fret with this forecast. Yes, I think the winter will be very warm. It won't be a blockbuster year by any stretch of the imagination. We're not going to have favorable patterns for most of the winter, but all you really need is 1 or 2 weeks to see a big storm. And I think that is our real only shot at having a salvageable winter. Overall, very warm, drier than normal for much of the East Coast. We're already seeing that right now in October, and I think that's going to be likely to continue as well. So, with that being said, thank you. I hope you enjoyed my winter forecast. Please feel free to leave any questions in the comments below. But that's it for my winter forecast. Stay tuned for any updates on Twitter. You can follow me at First and Weather on Twitter. And yeah, thank you again for watching. And here's to hopefully seeing another winter that might surprise my expectations. But overall, I think for winter weather lovers, next year might be the better bet. Thank you.